Distinct sample moments is
Started running the sample. How to run from there? If you take it, it'll be good.
okay. All right. Okay. So we had set this analysis property, right? So we had said we'll look at the standardized estimates, modification in the indices, test for normality, and so on. Then we ran this model, right? So this is the icon to run this particular model, and it says calculate estimates. So once you click on this, you will start seeing this icon says view text. Basically, this is to view the output of the AMOS, right? So once you click on this, you will get this window. Okay. Now this is the default. This is the window. By default, it opens up and it says it is showing us the notes for the model. So there were the variance covariance matrix had 55 items. Okay, so this is basically k plus 1 by 2. We had 10 items, so 10 into 11 by 2. Then the number of parameters to be estimated is 23. Okay, we have seen how 23. How do we get 23? We get it by number of factor loadings. What is the number of factor loadings here? You can see in this factor there are 2 loadings. Similarly, in this factor there are 3 loadings. One loading is tied to 1, and then in this factor there are 2 loadings. So there are 2 plus 3 5 plus 2 7 loadings. Then there are 10 measurement errors. Okay, so that makes it 17. Then there are 3 covariances, 1, 2, and 3. So that makes it 20. And then we have 3 independent factors, right? So it becomes 20, 23. Okay, so this is the output on the parameters to be estimated. So degrees of freedom is k plus 1 by 2 minus hash theta. This is the chi-square degree of freedom probability. Analysis, nodes, variables. These are the observed items. So these are the 10 items. So EMP 1 to 3, TO 1 to 3, 4, and LEX 1 to 3.
Trying to run, it says that 6 variables are unnamed, though I have named everything.
6 variables are
unnamed. When we run this, it says 6 variables are unnamed.
Okay. Can you share your screen?
Not possible, sir. I'm on a different system working because the.
Okay. So maybe what could be happening is, Swati, like when you drag, you have dragged it and put it here, but you have not dragged and put it in the rectangle. So you should, when you put the variable, when you bring the cursor over the rectangle, it should be highlighted in red. If you have not put it, so if you put it like this,
Okay.
the item is lying there, but it is not connected to this latent factor.
Okay.
So maybe just check.
Yes.
Maybe that could be a problem. Okay. Yes. Okay. So parameters we have seen. So parameters, there are unlabeled 7 loadings, 3 covariances, and 13 variances. 10 of the measurement errors, 10 of the measurement errors, and 3 of of the independent latent factors. Then assessment of normality, we were seeing this, okay, the normality thing, that multivariate normality is quite large and the critical ratio is also uh, showing that there is multivariate non-normality, though the items, kurtosis and skew is not that much, but together the data is non-normal and ordinal data is always non-normal, okay. Then we were looking at the Mahalanobis distance. So we did not see any significant break in the trend of the distances. So we say that there is no outlier here.
Sir, may I say-
Yes, go ahead.
Sir, this Mahalanobis d squared distance seems interesting because if it is very large, it can identify an outlier.
Yes.
Can this be used to cull out non-sincere participants? Non-sincere participants who have just filled or punched the number.
Yeah, so if you get a significant break here, then you should drop those cases. So this means that you should go to your data and drop the 86th case, because that case is showing that it is maybe an outlier. So you drop that respondent's data from your sample.
Clear, sir.
Yeah.
Thank you.
Yes.
Sir, is there any?
Yes, Shilpi, go ahead.
Yeah, okay, sir. Sir, as you already mentioned that when we are using the Likert scale, we will be having a multivariate
Non-normal.
non-normality. So, do you suggest that we will use the bootstrapping before
Yes.
we run the data?
No, you don't do it before you run the data. You run bootstrapping along with your data, along with the analysis. So it is a kind of an analysis, right? So when you will report the results, as of now, I'm just showing you the results without bootstrapping, but we will see later on the results with bootstrapping.
Okay.
Yeah. So we will run bootstrapping on our data.
Okay.
Bootstrap algorithm on our data.
Sure, sir.
Yeah.
Thank you.
Sir, you said the data is multivariate non-normal. What is the benchmark for knowing that?
Yeah, so this non-normality, so this critical ratio here, it should be less than, so if it is greater than about 2.5, right? This means that the data is multivariate non-normal. This critical ratio.
Okay, so that means CR greater than 2.5, right?
Yes, 2.5.
And what about the 29.010?
So this is just a number. This is just
Okay.
a number. We look at the CR here.
Okay, and sir, shouldn't the skewness and the kurtosis be between -1 and +1?
No, the kurtosis, we say it is usually plus minus 3. Okay, so that is the kurtosis number, and skew, yeah, plus minus 1 or plus minus 2 is something that is considered to be okay.
Okay, thank you, sir. Thank you.
So here we are seeing a lot of items do not show a very large skew, and for kurtosis, all the items have less than 3. Okay, value. So individual, if you look at it, not so much of a problem, but together there is non-normality in the data.
Okay, thank you.
Yeah. Yes, Kishore?
Yeah, actually, when you're showing the Mahalanobis table, that time, what does that P1 indicate? Because it's slowly increasing as the values are going down.
Yeah, so it is just showing the probability. So there are two probabilities which shows whether it is significant or not. The distance is significant or not. So it is a significant distance, but what we usually look for is the trend in this distance. And the trend does not indicate that there is any case which is which is working or any case which is behaving differently as compared to the others in the data.
If we get any data which is different, so can we remove them as outliers?
Yes, yes.
How much percent can you remove it?
How much percent? Well, you should look for all those cases which are showing a significant difference. So usually greater than about 5 points. So here it is like 39. If you get something like 46, 47 or more, then you should actually start thinking that this is showing a significant departure from the other cases.
Okay, so if it is pretty means more than 4 or 5 points, then we can think of removing it.
Yeah, about 5 or more. Yeah.
Okay, okay. Thank you, sir.
Yeah. Yes, Shubhanshu.
So this is in relation to my previous query. Can we go back to analyze properties? Analysis.
Analysis.
Yes, sir.
Okay.
Here,
Yes.
sir, next to estimation, when we click numerical tab, right? Then there comes the try to fit unidentified model. This was I was asking about.
Okay, okay, okay. Okay. So usually we don't do it. I would say if you get any identification problems, you should try to resolve it yourself rather than forcing the tool to resolve it.
Okay, sir.
Yeah.
Thank you,
Yes.
sir.
Yes. Yes.
So, but in that case, this is under identified model, right?
Yeah, I think so. It should be under. We don't use the term but yeah, it should be under identified. Yeah.
So actually, in some book, I have read to click this in case of unidentified model. That's why I asked. Thank you so much.
Okay. Yes, Dr. Vivek.
So when you were explaining the normality concept, you told that the Likert scale is actually ordinal and not interval.
Yes.
But what we have studied till date and what we were using in ANOVA and all t-test and Z, we were assuming the Likert to be on interval scale.
No, that is wrong. Likert is an ordinal scale. Likert is not an interval scale. Likert is used as an interval scale in all our analysis. But if you were to ask pure statisticians, okay, they would actually tell you that Likert is not an interval scale. Because what is an interval scale? Interval scale, first of all, it means that the difference between adjacent points is similar. Distance between 1 and 2 is the same as difference between 2 and 3 and so on. Which cannot be said in a Likert scale. We cannot assume that the difference between strongly disagree and disagree is the same as agree and strongly agree, right? These are just some numbers that we assign to these degrees of agree. For example, degrees of agreement. But we cannot say that these distances between two adjacent numbers is the same. So, and it is definitely not a continuous scale because it has limited options 1 to 5 or 1 to 7. So it has been found in statistical computations that a Likert scale, if you have a 4-point Likert scale and more, that means you have the points on the Likert scale is 4 or more, then you can use it as the kind of computations that you do in a normal interval kind of a scale. But there will always be problems of non-normality in a Likert kind of a data because it is not a continuous data. So it is not an interval scale. It is an ordinal scale at the end of
Sir, I have one last question. I'm using AMOS 26 over here. I'm not able to find these model indices or minimization in history and so on.
Okay, so you are not getting.
I'm not getting this. Normality assessment of normality.
Have you marked it in the analysis?
No, I guess so not.
So how will you get it?
So how do we do that, sir?
So you go to analysis, property.
Yeah.
Then go to output.
Okay.
And then test for normality and outliers.
Got it. Thank you, sir.
Yeah.
I'm just reading.
Okay. All right. So then nodes for the models, then the estimates. Estimates is the output. Okay. This is the unstandardized. When we say regression weight, this is the unstandardized output. And then standardized output is in the second table, which is here. This is the standardized coefficients, and we usually report standardized coefficients in our research paper. Whether they are significant or not, you can check from this p-value. P-value triple star indicates that it is p less than 0.001. Then we have the covariances between the three factors: EMP, task orientation, LEX, EMP and LEX, and these are the correlations. Modification indices, right? This is
sir, sorry to interrupt you. I want one question from estimates.
Yes.
Sir, so when we report CFA in our paper, we report standardized factor loadings, you're saying?
Yes, yes.
Okay, so these estimates are factor loadings itself. 0.8.
Yes, so standardized regression weight that you will see is the sorry, I clicked at it actually. So the standardized regression weight is your factor loading.
Okay, and we need to report it for all items.
Yeah, yes, you will obviously report it for all the items in your model.
And sir, in this case, in this itself, we'll get to know that the items which we have got in EFA as the constructs, whether these are matching in this or not, because it's a confirmatory.
So you are getting all the loadings to be good, right? Above 0.7. We said we can go up to 0.5 also, but here every loading is above 0.7.
So we'll take all the items here.
Yeah, so all the items are very good actually.
Okay, sir.
And they are highly significant as well. Right? They are all significant at p less than 0.001.
Okay, sir. So we need to at 0.001, or we can check it at 0.0.
0.01, 0.05, 0.05. You can go up to 0.05. Yeah.
Okay. Thank you, sir.
Yeah.
So one more small doubt is there. Why do we get different factor loadings while we run EFA and AMOS? We get a slight difference in the factor loadings. Why so, sir? What is the reason?
Because of the underlying algorithm here. So here the algorithm is maximum likelihood. There it is not maximum likelihood. There it is a principal axis factoring method, which is not a maximum likelihood method.
Okay, sir. Okay.
Yeah.
Thank you so much.
Yeah.
Yeah, sir.
All right. So now we come to the modification indices, and this is where we had stopped. This is the table that shows us how you can improve the fit of the model.